Okay, I think we are live now. So welcome at this next colloquium for 25 years of IPN. And today it's my pleasure to introduce Anna Paiva. She's a full professor of artificial intelligence in the Department of Computer Science and Engineering at the University of Lisbon, and also a senior researcher at INESC-ID and a fellow at the Radcliffe Institute for Advanced Study of Harvard University. Her work focuses on the creation of autonomous agents and robots capable of interacting and collaborating with humans. In 2000, she founded GAIPS, the Group on AI for People and Society, which is one of the international leading groups in social artificial intelligence, and she led this group for 20 years. She's received a lot of awards, for example, the Young Engineering Innovation Award from the Portuguese Order of Engineers, triple AI Blue Sky Paper Award in 2018 for pioneering work in prosocial computing. And what I found very interesting, in 2022, she was internationally recognized as one of the 50 women that know about robotics. I would hope there are a bit more in the world that in the end know about robotics, but I think this means that you really know a lot about them. And she was also named a woman in robotics, engineering and science at IROS 22. And so she's done a lot of scientifically interesting things, but also very interesting. In 24-25, she actually served as a Secretary of State in Science for the Portuguese government. So she does not only do research, but she also has a lot of scientific or national, societal impact. And she told us that it's been a while since she's been giving a talk, so I'm very much looking forward to it, and I think it's an honor to have you here. So, Anna, the floor is yours.
Oh, thank you so much. Thank you so much. Thank you for a nice introduction. And as you said, I did research in AI and artificial social intelligence for a while. And in the last 2 years, I would say, I was away from research. So this talk is like my comeback to research, but it's also a reflection or a kind of I came back thinking what I've done in the last 20 years and how I can change or what should be done in the future. So let me start by saying that my talk is about artificial social intelligence, and I truly believe that this is a missing element, a missing layer, a missing aspect of today's AI. And let me convince you of this statement. We all know we spend a lot of time with each other, and there's data that shows that we spend about at least 20% of our time, if you take out the sleeping and so on, engaged in social interaction. Social interactions is one of the main elements of our life. And that means that with the rise of AI that we know is happening, and especially Gen AI, we are seeing the emergence of hybrid societies of humans and AI, especially in this social context. And in fact, we've seen in the last few years the rise of artificial companions. And we know that people that rely on these artificial companions need support from these companions, and users, people that have less human support, are also more likely to seek to look for these chatbot companions. And the interaction of, with these companions is a lot. And in fact, we even know that some of these companions are treated by users as their romantic partners. So we really are in a world where AI is entered that our social world. So we cannot talk about artificial intelligence, and in particular about artificial social intelligence, without talking about the social aspects, without talking about social intelligence. And we know that, but what does it really mean to be social? And I started reading a lot about social intelligence in the last few years, and one of the aspects that really sticks out and comes as important is the fact that social intelligence is a different type of intelligence. And in 37, looking for a measure of intelligence in humans, Thorndike divided intelligence in three categories: abstract, concerning with his ability to understand and manage ideas; the mechanical intelligence associated with understanding objects and how they operate; and social intelligence, which is our capability to understand and interact with others. And in fact, this important social intelligence is so important that it's there are some researchers that consider that the intelligence that we see in humans evolved not primarily to solve practical problems like hunting and using tools, but mostly because we humans need to navigate our complex and social environments. The working in our social context, recognizing others, predicting their behaviors, deciding together, collaborating, understanding, resolving conflicts, all of this is part of what it means to be social intelligence. And in fact, the work by Dunbar, which I think is amazing, the work that is done in terms of friendship and the social brain, defends that the social brain hypothesis is that certain species have the neocortex size bigger, and that there's a correlation with the group size of the species, in this case the primates. So basically, social intelligence is core to our intelligence, to our interactions. But how do we come about thinking about the social intelligence so that we, as computer science, and I have to say, I'm a computer science, I work in AI, I've been working in AI for many years. How do we go about understanding the social interactions and bringing those social interactions and what we know about social intelligence into the realm of computer science? So I think there's at least 4 elements that are essential to think about. One is to do with social understanding, with the capability that we have of perceiving others, to put ourselves in the shoes of the others, of remembering social situations, predicting how the others are going to behave. So this social understanding is core to our social intelligence. The other one is really the communication itself, about effective verbal communication, attention. When someone looks at you, you look at them. Our non-verbal behavior is super important in these interpersonal competences. And all that leads to the development of relationships and adaptation to the others. Then we have to take decisions and to act in a social context. So when we collaborate with each other, we use social understanding and our interpersonal competences, but we also take into account the others when we do our reasoning, when we collaborate, when we do the bonding, when we're part of the group. So all that, the social decision making is important for us to be able to interact with others. And finally, I think this element is even more important and is often forgotten and disregarded, which is the fact that when we're in social environments, we look at the social as a core. We look at social responsibility, and that includes moral decision making, looking at norms, and again, prosocial behavior, which is very much related to some of the work I've done some years ago. So these four dimensions, I think, are the core for us engineers to look at how to develop new ways for AI to interact with humans. And you may say, oh, well, this link between AI and social intelligence is something new that now we have because we have the large language models. I would argue that that's not the case. In fact, if you think about the essence of AI and the work in the 50s, when AI became a field of study, you look at the work by Alan Turing, and you think of the Turing test, and the Turing test, in essence, is to test the capability of social intelligence. When someone cannot, the examiner or the person that is on the side of the screen trying to decide whether it's a computer or a human, in reality, is testing the capability of social intelligence. And not only Turing, but later on in the community, Alan Newell proposed the idea of the social, the model of the social agent, where you go from the basic knowledge to knowledge that has to do with the cultural, with the society, and competences that also go into a cognitive architecture that takes into account the others. Moreover, if you look at AAAI 94, we're talking about 30 years ago, more than 30 years ago, Barbara Grotz already was talking about these competences for collaborative systems, because this is how AI should go. So, in fact, social AI has been in the area of AI for a long time, but often ignored. Moreover, I like to show this slide because I think it's important. I used to use the OpenAI software, the GPT models before ChatGPT. And it was a very good experience. I used to generate poems with it and so on. The jump that occurred 3 years ago, 3 years ago, was a jump that has to do with human labelers demonstrating and kind of reinforcing what is better for human. So it's like creating a layer that leads to more natural interactions, more what humans want, and therefore it's all to do with social intelligence. And in fact, if you ask ChatGPT about what is a social system, is if social AI is there, it would say, well, a little bit, but not all. And in fact, all of these is something that many of us researchers in the field have looked at. And there was an event in 22, I think, in the Netherlands, where we discussed these artificial social intelligence organized by Cohen and Hughes. And I think there we discussed the need for this social intelligence. And we define artificial social intelligence as this capability to perceive and understand the social signals. So the component of social understanding, the component of participating in social interactions, the interpersonal competences, the component of acting, of making decisions with others, and finally the component of social responsibility and being in a social group. And as I say, that can become the building blocks and the functions that we want to build into our agents and our robots. So with this in mind, let me now give you some examples that will address some challenges that we have. And then I'll discuss better the situation at the moment, and then what I think we as a community should do next. So challenges. We have challenges to develop artificial social intelligence. One, I think it's one of the core challenges has to do with the lack of data. And the lack of data in the sense that we don't know what happens in some social interactions. And I've been involved in the last few months in a project where we have a robot with 3 people talking in a podcast. And it's been extremely hard to develop because there's not data. We are using an LLM, but it's hard to really make it so that it makes sense for a group to be interacting and discussing. And then there's a limited perception. There are limited perception mechanisms. So far, a lot of the perception is to do with text, with audio. But when we interact in a social context, we interact with all our senses, with our bodies, with the context in which we are important for those interactions. Moreover, when we talk about robots, we also need to think about the embodiments and the fact that for this interaction, there's different modes of expressing and the nonverbal behavior that you may be able to do with one robot, with one embodiment is not the same as with the other. And therefore, you need to consider all that into the equation that you want to produce these expressions. And then finally, I think the social responsibility and moral issues is something that there's a lot of discussion, but there's not so much that we know how to really endow our models, our systems with these, without being too prescriptive, without really not limiting the interactions. So let me now focus or give you a set of examples that are based on work that my team has done over the years. And these examples try to illustrate some of the challenges and difficulties that we've had over the years in order to build some elements, I would say, really little elements of this social intelligence. So let's start with the examples. One of the examples that I like to show is from a European project, the MODE project, that we had the challenge to create a robotic tutor to interact with 2 kids and teenagers. And they would be together as a collaborative group, trying to manage a city in a sustainable way. And our robot was programmed so that it would help the group to achieve a more sustainable city, trying to teach about sustainability by using this game-like environment and social interactions in this multi-party setting. And we realized from the beginning that it was very hard to know what the robot should say and how it would interact with the teenagers. So what we did was we created a Wizard of Oz, and with that Wizard of Oz, we recorded all the actions that the wizard was doing on top of mock-up studies that we had done before, so that then we built an algorithm to learn from the wizard. And this was important. Why? Because we didn't know really how the robot should act. So we wanted to see how the wizard would do and learn from the wizard. And this approach allowed us to create a data set, a data collection, and a data set of social behaviors. We extracted them, and that was then done and used to build the actual intelligence of our robot. And I think we actually used something even more interesting, which was we limited the perceptions of the wizard so that the perceptions were filtered by the perceptions that the robot would have itself, so that we could really learn from the actions of the wizard. And that led to the creation of a robot. In fact, we created two versions, one that was with all these components, which we call the empathic version, and then one that didn't have these elements, that was the empathic version. And then we tried to assess whether these mechanisms that we built into the behavior of our robot actually had an impact in the kids' learning, in the teenagers' learning, by looking at the results in terms of learning, about the factual knowledge that they learned, and especially looking at critical thinking, which I think is super important in terms of understanding sustainability. And to do that, we conducted a big study with 3 conditions: without the robot, with the robot, but in the empathic and the non-empathic condition. And we had 63 participants, and we collected several measures to assess the impact of our robot. And what we saw was that indeed the robot, the version that we consider the empathic one, led to more meaningful conversations. So the participation of the robot in the conversations amongst the teenagers and with the robot led to more conversations that are more guided towards what we wanted them to learn, so more meaningful for the subject that we want. Not so much about discussing about the rules of the game, or discussing about the getting the points, but more to do with sustainability. And that had an impact. And I thought this was really important result that we got. The other thing that we did, let me just stop here. The other thing that we did was to look at a long-term study. We looked at the first session and we looked at the last session of the same groups of students after a month interacting with the robot. And what we found, which was interesting, is by the end, the teenagers would treat the robot in a way they knew what he was going to do more, but they treated the robot more like a partner in the game. They knew that he would do this and that. And at some point, they even included the robot as a member of their team. And in this video that I'm not going to show because it's a bit too long, these two girls even do high five to the robot, because the robot became part of their team. And of course, you say it's very limited. I know it's very limited. The social understanding was very limited. The interpersonal competences, again, very limited. There was hardly very strong social decision making, but it had elements that were important for establishing these relationships. And I think the most interesting is the fact that we use this method of learning from the wizard in order to build the intelligence. So let me jump now into a second system that some of you probably have seen, but I like to show it because it's to do with it's a very personal project in the sense that there's a game, a Portuguese game, a card game of two teams of two people. So it's played with 4 people, and it's a typically Portuguese card game. If you walk in the summer in the middle of Lisbon, and the picture up there shows people playing in the streets, in the streets of Lisbon, and you see especially elderly playing this game because it's a social game. And I love this game because I used to play with my grandfather when I was a kid. I used to play at the beach, and he would give me the role or the pleasure to be his partner in the playing of the game against 2 experts in playing Sueca. So proud every time I played this game at the beach. So for me, I always associate the Sueca as this game that is very much about trust. It's very much about social interaction, and it's a game that the elderly play constantly. So I wanted to look at this game, especially because we know we are at a point where people need more interaction. So we decided to create a robot that plays this game. And here we have we've built 2 important competences: the interpersonal competences in terms of verbal communication and attention, and at the same time decision making, because the robot has to play the game and combine the decision making in terms of collaborative, because it has a partner, the person in front of it, and the opponents in the game. And what we did again was to collect data from an elderly center in Lisbon. And with that data, we use that data and the way they interact in order to build the social component of our robots. So the utterances, gestures, gaze, and so on were inspired, were guided by what actually happens in when 4 people play the game. And you can see now here how it is. I hope you can hear.
Games. Oh, ho, ho, ho. What if a robot could autonomously play a card game with you?
Ah, já cá estão todos. Eu estou web e vou jogar a sueca convosco.
Human players use physical cards on a tangible touch table to simulate a real card game experience. This robot autonomously managed 2 tasks: playing the game competitively and socially interacting with other players. This robotic game player is competitive to its opponents and cooperative to its partner. In this case, the robot's partner is the participant in front of it, and the other 2 are its opponents.
Estás com medo? Eu confio em ti.
Confia, mas
Ainda não recolheste. A jogar assim, ninguém nos para.
Its emotional state is expressed through its posture and animations. Participants answer the robot when it talks to them.
Ah, é?
Eda, soma 15 pontos.
Ai, gosto dele, logo os pontos.
And they also engage in a conversation spontaneously.
É, nada do meu jogo. Vês? Ai, vamos vencer isto, Emi. Ganho.
Ora bem, mais 2 vitórias para nós.
Okay, I'll stop here. I think you can see the social behavior and the expressions and the way it interacts with the participants is very natural and so on. Now, we evaluated these in many studies. I will just mention two of them. One was to do with trust, where we tried to test whether people would trust a companion like this. And what we realized was that people trust more a human than a robotic companion. However, after interacting with it, they would increase their trust in the robot. And I can tell you that I like to play as a partner of the robot because he played very well. So it's the trust is also to do with how much you know about the robot. But the other thing that we did, and I think it's very much related with what's happening at the moment, is to do with individuality. So the robot can have different ways of playing, different ways of interacting, and that has impact in the team. So we created two behaviors, two different types of behavior for the robot, created two robots, and created a nice one and a competitive one. And with that creating of individuality, something that nowadays people are looking at, because some of our chatbots associated with the LLMs, they do exhibit certain characteristics of personality. But we need to study that. We need to see what's the impact that has in the interactions we have with our AI, with our chatbots, with our robots. So we created two, Emis and Glean. One was very competitive, Emis. The other one was nice. He would say, oh, we're doing so well, whereas the other one would say, no, we have to win this, and so on. Very competitive. And then we did a study where people would interact with both of them, chose one, and then interacted again, and then at the end they would choose another one. And what we found, which was very interesting, is that at the beginning, people would prefer the nice one, Glean. But then at the end, it depended very much on the type of personality of the people. And people prefer artificial teammates that are more compatible with them. So nice, more competitive people at the end would prefer the more competitive robot, whereas the other ones less so. So this type of characteristics that we endow our robots and our chatbots with have different impacts on the people, and that needs to be studied. And another interesting thing was people gazed differently at the different robots. For example, they gazed more at the competitive robot than the other ones. And that is something that, again, needs to be studied, because we can build these types of differences in the behavior of our robots, and that will have a different impact in the users. So again, I will go back to my scheme, my 4 dimensions, because I think it's important. Again, the social understanding was very little, but it had some interpersonal competences. The social decision-making was good. And we had also this aspect of individuality. So let me now jump into another project that's more to do with the different embodiment and the capabilities that the body has in the interaction with humans, and in fact in establishing when you start the conversation, you gaze, you do a handshake, whether that has an impact or not in the users. And this work is to do with handshakes, because I think this was very much also influenced by or had an impact in how we see the handshake, and the pandemic led to us thinking about these social interactions and the role of touch and handshake in a way. So this handshake capabilities or characteristics of a handshake and the impact of a handshake was studied with the robot from the Robotics Institute. And we used the fact that this robot has an arm and a hand with, and it has 30 degrees of freedom. So the arm and the hands are really good for social interactions, and not only for manipulation, but also to do handshakes. And we used that in a scenario where the robot had to do a task, and the participant also had to do a task which involved going from one part of the room to another and count some images that are some squares or elements that were in this picture. But as the robot would go there and the person would go there, there was a table in the middle of the room that would make the robot incapable of passing. And you can see here how it is. There's a handshake. Okay, and then they go and they start and you pass, and what happens in this case is the robot cannot pass, the person gets back, and the robot is incapable of performing his part of the task. This one here is similar, but in this case, this participant had a different behavior, so they were both going, and then as they go, oh, no, this is not what I want. I think it should be another. Let me see if this is it. I'm sorry. There's a handshake. And then they start going. And then the robot is there, stuck. And yeah, the participant realized, oh, we can't pass. So the participant helps the robot. Now, the interesting thing of this, does it make any difference? Well, I can tell you that the handshake version led people to feel more willing to help the robot, and they helped the robot more. And in fact, it changes also how they feel in terms of warmth, how they feel in terms of animacy and likability in relation to the robot. So this is interesting because just a small gesture or a small type of behavior, social behavior by the robot, has an impact in prosocial behavior by the user. And of course, you may say, well, but the robot is not prosocial. I know. That's why we started looking also into the prosociality. And I have this mind that this idea that we should be building AIs and agents that really take social responsibility and perform prosocial behaviors and helping the society as a whole. And that entails following norms, having moral decision-making, and prosocial behavior. And I defined some years ago, prosocial computing has the area of computing that is directed and supporting and promoting actions in a group or society that benefit the society and the others. And I can tell you that now, having been in science and science policies for a while, it's important that we all know that science is contributing to the common good, to the understanding of the world, and this common good is something that benefits all of us. It doesn't benefit just the individuals that contribute because they get more papers, but it benefits the society as a whole. And that is so important in science. Anyway, using this idea as the basis, we explored that in human-robot teams, and we created 2 robots that play a game, a collaborative game inspired in a collective risk dilemma. So the players can either cooperate or defect. It's an n-player collaborative game. And we created 2 robots. One that was a little bit selfish, that wouldn't contribute to the group, and one that was prosocial and was contributing to the group. And the prosocial, of course, you want, if we want the best for the group, the prosocial has a stronger contribution for the group. And I can show you the video where a user interacted with these two robots playing this game.
No, scuola, un fracasso. Guarda, desgraça.
Hemisfério negativo.
Então você vai, fracassou.
Oh, não fico triste.
So these are the two robots, and I like this video because it shows really a kind of team effort and how she was feeling and having emotional responses to the results of the team, and was consoling the robot, the prosocial one, because he contributed so much, but in the end the team failed the scenario. And what was interesting was that as we then studied these scenarios, and we saw that the prosocial was people felt more warmth towards the prosocial, and they felt more discomfort towards the selfish. But also we asked who would they like to partner with, and what we found was that if they were winning, it didn't matter so much if it was the prosocial or the selfish, but if they were losing, then they would prefer to partner with the prosocial one, and realize that this has impact in the way we build our chatbots, that we build our AI, because we want to good results in a team. So we want and we want people to select the partners that really help them, help the society to achieve a result, and therefore the winning and the losing changes your perception of the robots itself. Moreover, there was an interesting result that we got to do with the fact that that we tested with different embodiments. So this was the result, but we tested with different embodiments. And what we saw that the embodied version, the prosocial was seen more negative. Okay, and therefore there's like some dark side of embodiment in these social agents. So let me now jump into discussing the current generative AI and what we're doing with these chatbots. Are our current chatbots social? And I believe that they are not. They have, like my robots, they have some effective, well, they have amazing verbal communication. They are much more eloquent than the average human and than me. But they lack social understanding, social decision-making, social responsibility. And because they do that, yet we are interacting with them as if they are companions, and people are using them for advice as companions all the time. But what do we have in these social, in these chatbots? We have the illusion of social competences. And this illusion is going very far. Think about, in the early days of AI, we had Eliza. People were thinking, okay, this is really a psychotherapist helping me, okay? There was the illusion of social life. But we know, as computer science, there's not much there in terms of understanding what's going on with the person, with the user. The same is going on now. If you jump into today's world and you start asking questions to LLMs and say, oh, I'm troubled by what's happening in the world. My best friend didn't invite. And he replies, oh, I hear, I'll tell you that you're not imagining the world is going bad, and so on. And then at some point, I tell him, I'll tell the LLM, can you help me? And say, I absolutely can. Look, this is not right, because our current LLMs, chatbots, are not able to really establish relationships. They don't have the social intelligence that I've just been talking about. They don't have sense of self. They don't have social perception. They don't have empathy. They don't care. They don't have social norms. No social responsibility. Yet, we treat them as if they have these social competences. And that's the problem. We believe that we're establishing a relationship when in reality we're not. So the question I have for all of you is, do we really want to give this illusion of social competences? Isn't there a danger there? I think there is. Therefore, I think we as a community should have a strategy for creating more safe human-robot relationships that rely on what I've just told you about building social competences in AI and robots, engineering these capabilities, study these relationships and these interactions in order to guarantee that what we're doing really has the right impact, regulate the use of AI, in particular AI companions, and increase with educational programs critical thinking and literacy in AI. I believe that these 4 steps are super important to create these safe human-robot relationships. And the missing layer is the artificial social intelligence. I believe that we need to look at these 4 components as part of our collective contribution to science and to the society to make our AI and our systems better. So my final message is social artificial intelligence is a missing layer of current AI. And I want to thank you. But before, I want to thank all my fantastic team, Filipa in particular, because she did a lot of the work that was here, Filipa. And a lot of my PhD students over the years, they are the ones that did all this work that I showed. And without them, I wouldn't be able to be here presenting what I've just presenting. Thank you.
Thank you very much. A very interesting presentation and very thought-provoking, I would say. If people have questions, just raise a hand, and then, yes, I see questions already. My Nava and Sanne will make sure you can use your microphone and switch your camera on. So, is that? I guess we're getting there. Yes, very good. Nava, please.
So first of all, thank you for such a nice talk. It's not the first time I hear you speak, but I enjoy it every time. You said that there was a negative effect of embodiment. And I'm wondering, is that embodiment nevertheless maybe something for us to seek maybe in a different way when we look at generative AI? Because we talk also about over-reliance in these systems, and maybe a little bit of lack of trust could be healthy sometimes. What do you think?
Yeah, in this case there was, but I do believe that the presence of embodiment, especially if the embodiment is more mechanical, is positive, because it leads to less illusion that there's more there than actually is. I think embodiment is it's hard to do, but I think can have a really good positive effect because it doesn't deceive as much than if there's no embodiment. Yes, thank you for the question. I go with you.
And other questions? So one thing I was wondering about, so you described the steps that we should take and to how to say it, so that we can that we have safe interactions with robots. But do you think it is also feasible, achievable? Can we explain this to people? Will people understand that it's important that we care about these things?
Well, I think these 4 steps for human AI and human robot relationships is more than just interaction, it's relationships.
Yeah.
I'm thinking about relationships in the sense that they are more long term, that they have this sense of who's the other and so on. And because we're seeing a lot of these developing, but only from the side of the human thinks he has a relationship with the AI, but the AI doesn't have a relationship with the human, right? So is it feasible? I would say that it's part of us, our role as academics to make sure that these aspects are discussed, raised, and implemented when we create our systems. That's in one hand, but it's also part of policymakers to be aware that there's problems that are out there and that we need to take into account what's going on, and the scientific community like us know about it. And the fact that I've been in both sides, it's helped because yeah.
Yeah, no, I understand. So what you're saying is also then that basically we have to make sure that things are safe enough so that if child uses, interacts with a robot, builds up a relationship, that we can just rely upon that it's safe.
Exactly.
Yeah. And then, well, thinking about that, you've been on both sides, right? So recently there was in the news about this AI minister in Albania. So
Yeah.
do you have any view on that then?
Well, I don't have a real a concrete view on that. I think that yeah, I don't. I think governments need to be aware and take into consideration what's going on. I think Albania went very far into that process. I wouldn't defend that, but yeah, I don't know.
Yeah,
I
no.
wouldn't
But
defend.
maybe we first have to work on relationships, and then after that we can get safe AI politicians or something like that. But that would be a next step. Yeah.
Exactly.
Yeah. Yeah, I'm looking if there are any other questions from the audience.
Yes, I have a question.
Oh,
Hello.
very good. Yeah.
Hey, thank you, Anna. Thank you for your talk. So I see in the media a lot of these like smaller startups developing like humanoid type robots, and also there's this recent collaboration with Google DeepMind and Boston Dynamics, and these robots by like Figure, you know, all
Yeah.
these startups from the Bay, and I was wondering. Do you have a timeline for when you think that this will become widespread? So say like we'll have robots in our house and interacting with, I know, our household devices and that. Because it seems like, you know, a lot of hype because we've got to please the stakeholders. But I was wondering what your take was on that. So do you have like a timeline for this? Do you believe in what they're selling or advertising?
Well, Okay, I don't like to make predictions because often when we make predictions, we're wrong about those predictions. In fact, I didn't predict what happened with Gen AI, and I wouldn't say if you asked me 8 years ago, I wouldn't predict what has happened anyway. But let me go back to the question of the current state. I think the real world, the physical world, is very hard, and we are oversimplifying the difficulties that we're going to have in interacting with that physical world. Of course, we have now a lot. So I think of the LLMs as this base, like this seed that powers the knowledge, so that behavior can be generated. But I don't think that's enough. We need world models. We need models of social interactions. We need a lot more. And there's robots being placed in the house of people, like the Neo robot now is placed in the house of people just to collect data. But I find it very hard to, I wouldn't predict that in a year they can have enough data to make a completely autonomous robot that interacts with humans in a very natural way and is able to interact in a household setting. So I think the predictions that are being made and the investment are a bit too much. I believe it will take more time than what's being predicted, because I think the task is very hard. It's very, very hard. And there's no data set. And not only the robots, the hardware, they cannot run LLMs. I know that NVIDIA is doing a lot to try to scale it so that you can run the models in the robotic platforms. But it's going to take a lot of time. I think there's some overestimation about how soon we're going to have these robots in our social environments. Maybe it's not what you wanted to hear, but that's what I feel.
It's your answer, so it's exactly what I wanted to hear.
Okay.
I see there was another question in the chat by Jeroen Oge. Do you want to ask this as well?
Yeah, sure. I can just repeat what I wrote down.
Yeah.
I was just wondering, since you talked about LLMs in this case, or also social robots being able to kind of mislead us into thinking that they are some kind of deep social being. So if I am, for example, interacting with such a social robot or LLM, how then can I be sure that these social capabilities are real in a way, or that they are being faked?
Well, for the moment, I would say they are being faked. But how can you know they are real? They don't have a human body. They don't have these characteristics yet. That's a very good question. I think that my understanding of what's going on at the moment is that because we're technical people, we know they're not real, but people that interact, they don't understand how the behavior is generated, and therefore they think they're real. So the only way to address this problem is by awareness, is by literacy around what these systems are actually capable of, is teaching children what they can expect or not. So it's more to do with teaching people how to really be critical in the way they interact with these systems.
Yeah, I agree. I also wanted to show my face because I realized I didn't do that before. So thank you.
Thank you very much for your question.
Okay, then I don't know if there's any other questions. Otherwise, I think we should thank Anna again for a very inspiring talk, and I enjoyed it a lot. So thanks very much for being with us today. And
thank you for inviting me. You know, it was my first talk since a long time. So yeah. Okay.
Yeah.
Thank you for inviting me.
And with that, I would like to close. Let me just end by saying that our next colloquium will be on February 19. And then Paula Herber will talk about how formal methods can actually help to make embedded systems more reliable. So I hope to see all of you back again then.
Okay. Thank you.
Yes.
Bye.
Bye-bye.